we forgot to record our class, our 8 a.m. class this morning, and we got into some pretty dark topics dealing with like Bob the Builder fan fiction. Hold on. It was made up, but don't Google it.
It doesn't matter.
Trust me, if you Google it, it'll be less okay. It really makes you disappointed in humanity, and you. Well, we started off talking about the. I don't even know how we got on the conversation, but bronies, the My Little Pony. There's a I think it's an all male fan group. That's in, and they have conferences and stuff like that. One of the students in there works at a movie theater by Kalahari at the Dells, and apparently there was a brony convention there. I don't know if it was over the summer or last year, but yeah, he's still recovering from the event, the events of that weekend, I guess. But yeah, so I don't remember. It probably was me who said it, something with Bob the Builder fan fiction or something, or maybe you talked about Bob the Builder canon. We were talking about Transformers and stuff. Yeah, this is a language theory class, so we get off on all sorts of weird twists and turns. But yeah, so then after classes, oh, I wonder if it's out there and it's disturbing. Like, don't Google it disturbing. Definitely don't Google it on campus disturbing.
Oh, so you had to use your phone's.
No, I didn't. It didn't block it, but it should have blocked it. And so it was very problematic. But it does make you disappointed in society.
Your first phone call is going to be to IT. Why aren't you blocking this?
No, I only admit Bob the Builder fan fiction lore in public environments. It's a hobby. All right, so let's start. We didn't have any homework for today, correct? All right, so let's keep talking about arrays. Actually, let me spend a few minutes. Let me spend a few minutes talking about the exam. Although officially, actually, no, we do need to talk about the exam. So midterm for us will be Tuesday. What's the date for Tuesday? The 17th? No. Is that right? Tuesday the 19th. All right. So next Tuesday, our next class will be set aside for the midterm. The exam will be online on Blackboard probably by Monday morning. So I should have it up actually a day before that in the morning. You will have to complete the entire exam in a single sitting. I won't put a time limit on it. The exam will be designed to take roughly 50 minutes, something along those lines. Even though class time's usually an hour and 15 minutes, it'll be like I don't want it to be a time stressed exam. That shouldn't be the reason you do poorly on the exam. So I won't put a time limit on it, but you really shouldn't have to spend any more than an hour and 15 minutes on it. If you end up spending more time on it than that, it's fine, but then you should really start questioning, why did it take you that long? And I would probably say that it would be interesting to see what your final grade is on it relative to how long you spent on it, because if you're spending significantly more time, you probably were not prepared for it. But you do have to complete it in one sitting. I don't care when you take it, as long as it's I have it submitted by midnight next Tuesday. So if you want to take it Monday morning when I first get it up, that's okay. I'm just guaranteeing that you have the class time available next Tuesday, our next class meeting, where you can you definitely have this period available because you're here, you would be in class. So we won't meet in person next Tuesday. That class time will be set aside for you to be able to take your exam if you choose. I will guarantee that I will be available live on Slack to answer any real-time questions you might have while you're taking the exam. So if you do have questions, I will be able to I'll answer immediately while you are taking the exam if you choose to take it during class time. next Tuesday. Remember, we do not have class next Thursday because we're on fall break. So any classes that meet after 4 p.m. Starting next Wednesday will not meet. So we have Thursday and Friday off for fall break, and then we're back the following Monday. So this will be our last class meeting until the Tuesday after fall break. Okay. Exam has 10 questions, each worth 10 points. My policy for midterm and final is if you do better on the final exam than you did on the midterm, I will replace your midterm exam score with what you earned on the final. All right, so you get a get out of jail free card. If you come in, bomb the midterm, perfect. If you come in and bomb the midterm, hopefully that ends up being a wake-up call for you. Come in, do better on the final exam. I will replace your midterm exam score with what you get on the final. Not the other way around though. You can't, ace the midterm, then blow off the final and get that guy carried over. At the end of the day, my job is to give you a grade based on how well you've mastered the material by the end of the course. I don't think a single day should destroy your chance of success at that endeavor. But if you do poorly on the midterm, at least use that as a wake-up call and find out why you sucked at it, so you can hopefully do better on the final. All right. As you work through our classes you'll take with me during your 4 years, you will have progressively more and more programming on the exams. Our early exam here, though, will have some programming questions on it, but not that many, and fairly easy programming questions because we're just starting to get into the world of programming. So, like a reasonable question on the exam might be to write a loop that displays to the screen the numbers between 1 and 10. Something like that. But I'm asking you to come up with this not by copying off some notes. It's closed book, closed note. You can have a calculator. You can use the calculator on your phone. Just don't use Google. Don't use a neighbor. This is an individual thing. The exam is just as much for you as it is for me. It tells you how much you've learned, because I do encourage you to work in groups and stuff on homework assignments. So it'll tell you, are you being extremely reliant on your groups to get your homework done, or are you actually learning from it? That's the goal ultimately, is to learn. So I'm not looking for perfect syntax on the exam. The expectation is there's probably going to be a missing semicolon and things like that. I'm not knocking points for things like that. I want you to show me, do you roughly, I grade pretty much on competence. Do you roughly know what you're doing? Can you write me a loop that has some print statements inside of it that pretty much accomplishes what I'm asking? Or have you basically left it blank and just drawn a smiley face or something like that, where you don't really know what's going on? Typically, when you're grading programming stuff, it's usually one or the other. Okay, there's not a whole lot of room in between. You either pretty much know what's going on or just clueless at this point. And there's going to be some of you that are currently, just struggling with it. And that's okay. You got to keep putting in those reps, but you have to ask yourself, why am I struggling? Am I not being productive enough on the homework assignments? Am I too reliant on a group? Am I not working on a group and struggling within my own and not getting anywhere? Try to give some rationale to why you might be struggling, so you can kind of go from there. Waiting in the waiting room here. Okay, so 10 questions, 10 points each. There'll be 2 or 3 programming questions, but on the easier side, just to kind of see, do you understand how variables work? Do you understand how loops work? And probably write like a simple function that does something. There may be a question or two where I give you some code. I asked you, what does this code do? All right, so you should be better at doing that right now. You should be, when you see code, you should probably say, oh, I know what that does. That's probably a skill that comes easier to you right now than if I asked you to write something from scratch. It's probably a truth for you at this exact moment. There'll be at least one, probably more than one conversion question. Convert a number from one base to another base, that kind of stuff. So in fact, I think there'll probably be at least 2 of those on there. All right, so what I'm going to do, so any high level questions about the exam, I'll flip through the slides here and kind of give you highlights of things that I think might be worthwhile spending some extra time on versus, yeah, probably not going to make the exam, but are there any generalistic questions about the exam before I do that? Go ahead.
How would you say, because I have everything done on both stuff,
Sure.
but how would I practice that without kind of already seeing what I did?
Well, presumably you haven't memorized what you did. So you could maybe take something, maybe one of the homework assignments or something we did in class and maybe change it up just a little bit. Instead of displaying the numbers between 0 to 9 100 times, maybe you're going to do 9 to 0 100 times, something like that. But try to write it yourself. Don't just say, oh, I'm going to copy this down and stuff. Bump into the same problems you ran into the first time and then see if you can kind of work some of those kinks out until you get there. And once you get a little bit more, some more skills under your belt, then you'll have maybe the ability to more easily invent some questions. I mean, even now we've looked at strings, so maybe you can say, well, I'm going to write a function that removes all spaces from a string. So I'll build a new string that is the original string without spaces in it. Just give yourself little utility puzzle type things like that to pull off. Anything else? Go ahead. No multiple choice. You'll never have a multiple choice or a fill in the blank with me. Yeah, I think those are stupid. Easy to write. Well, no, hard to write, easy to grade.
Yeah, multiple guess.
Yeah, but that's what the, yeah, go ahead. You can come here in person if you want. I won't be here. I mean, I'll be in my office probably, but the exam is on Blackboard, so you don't have to be sitting here. Go to wherever you're comfortable so you can sit there and take an exam on Blackboard, unless you choose to take it at a different time. I want it in by midnight on Tuesday, but I can just guarantee that everybody in this class has this time slot available to take the exam. So nobody's going to be able to say, oh, I just don't have time. You have this time to take that exam. You can choose to take it at a different time. You can do it Monday or whatever, but I'm promising I will be available in real time to answer questions on Slack during class period on Tuesday. So no, you shouldn't attend class, but I do expect that many of you may be taking the exam during that time online. Yeah. Let's say no. Yeah, so what he's asking is, if you when you're answering the questions, should you use like the online compiler to like test it? I don't want you to do that because I don't want you to be debugging your answer until you get it right. That's for 2 reasons. One is time, and secondarily, I want to see your approach. I'm not looking for perfection. I don't care about that compile error where you forgot a semicolon or something like that. I'm basically measuring where is your current level of computer programming competency, completely understanding that at this point, we've only kind of just begun. Most of us are not going to have a real high level of competency. So the questions I'm asking, take that into consideration. So this is going to give you that idea of, am I competent enough where I should be in this class, or am I dragging behind? Programming is hard. I advertised that day one, and there's going to be a good chance some of you are going to just horribly bomb the exam. And that's okay. That should be your wake-up call. And that's why you have the get out of jail free card with and all my classes do that. Up through your senior level classes, your final exam will replace your midterm if you do better in it. Okay. Yeah. Other questions? All right, so let's start flipping through the slides and I'll kind of tell you things that are extra important that you might want to really make sure that you practice to review for the exam versus things that are important but probably not gonna make a show. This slide, I would say, is extremely important as a foundation for really all my classes. I don't know if I would ask you to like regurgitate this slide, like, you know, how do human beings solve problems and how is that mapped to computer programming languages, but it would certainly be fair game. So I would say make sure you understand the concept of this slide and how that maps to what our programming languages do for us. Nothing about HTML. I mean, it would be fair game to ask a question like, what's the purpose of a programming language? Although I would probably have to be pretty desperate for a question to ask that specific question, you know, tell a computer what to do or something, but you should definitely understand what programming languages are and why they exist and what we're trying to accomplish with them. Stuff from this slide, certainly the high level, low level, machine level comparison, the difference between those kind of languages, what a high level language is versus a low level versus machine level, certainly compiled versus interpreted, and loosely typed versus strongly typed. Those last two, I would say don't worry about right now. But the high level, low level, machine level, that's kind of when we had our discussion about how CPUs work with, you know, their collections of magic tricks. And we looked at like hello world and Linux. And, you know, I'm not going to ask you to write assembly code or even read assembly code or something like that hello world thing. But you should understand this concept that C++ is high level code, very much English-like. Every line of code we write translates into a whole bunch of magic tricks on the CPU. Low level language is kind of like what we looked at on that program online, the hello world in Linux, where, you know, it was much more cryptic. One line of code is equivalent to a single magic trick on the CPU. And then machine levels are zeros and ones. Also understand compiled versus interpreted. Specifically, you know, compiled languages, we translate to low level prior to running it. Interpreted languages do it in real time. C++ is a compiled language. It's also a strongly typed language where we have to define the kinds of values our variables are built to hold. So things involving these concepts, these top three, are going to be represented in one way or another on the exam. Know what a compiler is, like I just said. Know this slide. Differences between machine level, low level, high level. Know this slide. I would say this might get a little bit too deep into the weeds for what I might ask on the exam, but, you know, this top thing is, you know, what does a compiler actually need to accomplish? We had this conversation about you kind of need to know what processor am I targeting, what operating system am I targeting, and then what's the language I'm writing in. I would say 10% chance or less that something like this ends up on there, but certainly an important topic. Won't ask an operating system question. Something about the CPU would be fair game. Really something along the lines of just understanding that CPU is effectively a collection of these little abilities, collection of magic tricks that each one solves some little tiny problem. And if you call enough of those abilities in a row in a certain order, real things get accomplished. I don't know what format that question might come as, but you should definitely understand that that's what the CPU is. All the conversion stuff, like I said, guaranteed. 20% of the exam is conversion stuff. You will have 2 conversion questions. Heck, you might even have 3. You know, if I'm desperate for an extra question, I might just pull a conversion question out. All right. Super important in here. And like I think I mentioned when we first covered it, every single exam you ever have with me will have at least 1 conversion question on it in any class. These are skills that all computer scientists should have. You learn about it in this class, but You know, that's something that we can do that other people don't necessarily know how to do. And there's a good rationale for why we need to be good at that stuff because of what our profession is. So make sure you fully understand what this slide is talking about. You know, the idea of like, if I have binary, the legal bits are 0 and 1, decimal, the legal digits are 0 to 9, octal, the legal octets are 0 to 7, hexadecimal, the legal hextets are 0 to 9, A through F. You know, and I don't care if you know what hextets and octets and those things, but the language of those numbering systems is 0 to whatever the base is minus 1. Those are the legal values you can use to build numbers in that. So if you're writing an octal number, those numbers consist of 0 through 7, some series of those. All right, know how to convert binary to any base. Know how to convert decimal to any base. So basically be able to go back and forth between any two bases. I would encourage you to review the tricks for binary to octal and binary to hexadecimal, because there will probably be, I tend to like to ask some question that has some really scary looking binary number that you're like, oh my gosh, I have to convert that to decimal and then to octal or something. When the reality is that you just group it into bits of 3 and you directly map it. Make sure you know that shortcut. That might make your life easier. Not that you have to do it, but I think it would be beneficial. So these are all just practice problems showing work and everything. So take a look at that. Here's those shortcuts, octal and hex, kind of giving that rationale of why those guys. There could even be a question just involving data. I might ask a question along the lines of, why is base 8 and base 16, octal and hex, why are these popular in computing? What's made them popular in computing? You know, that idea that the entire octal number system can be represented in 3 bits and the entire hexadecimal number system can be represented in 4 bits. And because of that, the convenience of mapping between binary, the language of our computers, and those bases is extremely convenient. So here's those 3 bits, full representation of the octal octets. And here's the 4 bits, full representation of the hexadecimal hextets. And again, this is not something you have to memorize. This is the binary number 0, 1. This is bucket. This is the 1's place. This is the 2's place. That's a 2. This is the 1's place. This is a 2's place. 2 plus 1 is 3. So these are just binary counting.
So that's binary to hex, but A through, right?
10, 11, 12, 13, 14, 15. This is the A, this is the B, C, D, E, F. All right. Definitely understand the concept of the modulus. So 3rd grade math, a remainder, long division with our remainder. You know, we used it for detecting primes. We've used it for detecting evens and odds. So that idea of being able to say, is some value evenly divisible by another value? It's a chance I could ask maybe one of the programming questions might require you to utilize that. So definitely be able to work with that. We're not talking about, like I said, this is 3rd grade math, but it's something that we're kind of out of practice on, and we don't think about long division very much because we've been dealing with decimal, floating point division for years and years and years and years. I know there's some like repeats and stuff. Possibility for data size stuff. We talked about this, a conversion question that goes from maybe, you know, if 7 gigabytes is how many megabits, something like that. So you go between these 2 columns, 8 bits, 8 of these guys equals 1 byte. There's 1,024 kilobytes, and 1024 kilobytes and 1 megabyte, 1024 megabytes and 1 gigabyte. So just like our previous tables, this isn't something you really have to memorize. If you could just remember 0 to 8 and then the number 1024, you can recreate this chart. Well, I'm just saying you need to remember 3 things. 1 bit to 8. So a 0 or 1 is 1 bit. 8 of those is a byte. And then this number 1024. And then you can literally write this chart with just those 2 pieces of 2.5 pieces of information, let's say. So here's an example of a conversion for that, be able to do those. Won't ask anything about that. I know some of these are repeated because I hit them earlier in the class, even though the slides were already generated. I probably wouldn't ask anything directly from this this slide, but you should kind of understand that we're floating in this world right here in this class, the C++ language. Definitely primitive data types. I won't ask you questions like how many bits is a short? So you won't have to tell me though a short is a 16-bit signed integer that can hold values between negative 32,768 and positive 32,767. I won't ask those kind of questions. Okay, but I might say list the primitive types in C++, or give me 4 of the primitive types in C++. Where our primitive types are byte short, int long, char, float double, and then bool. Okay. So you should know that those guys exist in the language where our primitive types are, they can only hold a value and they're built into the language. Probably won't ask you a question about character sets, but it is important. Let's call this a 5% chance. Alaska character set, C++ uses ASCII, but Unicode's a superset of that. So the first 128 characters in the Unicode character set are the same as the ASCII character set. Like I said, general purpose first, domain specific. I'm not going to ask anything about that. It's not that it's an unimportant concept. We just don't really have an example of it for us in here. So unimportant for us. Object-oriented versus procedural. I guess it's outside possible that I would ask something, kind of we had our procedural telephone versus our object-oriented telephone, but really we're going to spend a significant part of the second 8 weeks dealing with object-oriented stuff. So that's going to be much more of the focus on the final. So I would say you don't even have to worry about this slide for the exam. I'll still steer clear of anything object-oriented because it's not in our wheelhouse right this moment. You should know where C++ does fit. I don't know how I'd ask this question, but one of the reasons why it's important for us to understand the different kinds of programming languages that are out there, because understanding where a particular language that we're using, where that fits in the world of languages, that can give us a bunch of information about how that language is likely to work. All right, and that will make more and more sense to you as you work through our classes. You get it to the 470 class where we're writing a programming language, you'll recognize how important that actually is. But at the very least for us, you should know that C++ is one of our high-level languages. It's a power tool for humans. It's strongly typed, which means whenever we create variables, we have to tell it what kind of value it's built to hold. Similarly, and more recently for us, whenever we create functions, we have to tell it what kind of value that function is expected to return. C++ is also a compiled language, which means it's relatively fast because we run it through a compiler, which converts it to code that runs natively on the CPU before we actually run it. It's an object-oriented language, even though at this point we haven't done any object-oriented stuff with it. this point, we've only done procedural stuff with this language that is capable of doing object-oriented stuff. And it's a general purpose language. It solves any kind of problem you can solve problems that involve programming languages with. Okay. I probably wouldn't ask you to like regurgitate this slide or anything, but there could be some question on there that relies on you making sure that you understand where C++ fits in the ecosystem of programming languages, somewhere in there. Definitely know what Boolean expressions are. Any expression that boils down to a single value of true or false. We use them in our conditionals. We use them in our loops. They're kind of our two places that we, so we use them in 2/3 of that slide that says, how do human beings solve problems? Remembering stuff, asking questions, repetition. 2/3 of those involve Boolean expressions. The ability for us to formulate true and false statements that can then be used either as a one-off, if something is true, do something, or as a repetitive thing, as long as something is true, continue to do this. Right, so definitely understand Boolean expressions, be able to create Boolean expressions, be able to create arithmetic Boolean expressions, less than, greater than, those things working with numbers, be able to work with ands and ors. All right, so Boolean expressions, I would say, are will be on the exam in probably multiple forms. You will have to ask, you will have if statements in your programming questions, you will have loops inside your programming questions. That's an important concept. Be able to write a conditional, so be able to write an if statement. There's your arithmetic Boolean operators. There's your logical Boolean operators. I won't ask anything about the bitwise crap. That was more of a heads up FYI in class. So, you know, you should be able to work with ands and ors. These guys. Not operator, I would say, is you might end up using it, but I don't think I would give you a question on there that required you to use the not operator. It's possible if I gave you code to read and said, what does this do? It would be fair game for me to use the not operator in that. So make sure you're familiar that with this exclamation point, that is the not operator. So not true is equal to false. Not false is equal to true. It just flips a Boolean. Okay. But none of these, you know, bitwise XOR, nothing, bitwise, none of the bitwise stuff. So this is our example of that. Just this exists. You don't have to. I'd encourage you to make sure you understand this, but you won't need it for the exam. Same thing, truth tables just kind of prove how these different guys actually work. I won't ask you to like write the truth table for and or. That would actually probably be a pretty easy question, but you know, it's nothing I'm asking you to regurgitate. Truth tables are more of the foundational basis for how Boolean expressions work. Definitely be able to create variables. Understand that variables require a type, variable name, and then a value. Questions. Like I said before, this is an important skill. There'll be at least one question on the exam where I give you some code and I say, what does this do? All right, and here, this is an important thing. So put a big star next to this in your notes. When I ask you, what does this code do? I'm not asking you to walk through it line by line, telling me what each individual line does. You can put that there. But what I'm really asking you is what problem does this solve? Does the current code reverse a string? Does the current code add all the numbers up between 1 and 100? That kind of stuff. I'm asking you to read through the code, understand what it's accomplishing, and telling me what problem is it solving. Go ahead. Yeah, make some sense? Yeah. Now, I'm not going to take off points if you go through it line by line, because I think that's an important thing, is resolve the code line by line. I'm defining a variable. I'm initializing it to this value. I'm starting a loop that's going to keep going as long as something is true. That's your process. I encourage you to do that, but that's not what I'm grading ultimately. I'm asking, can you look at code and ultimately tell me the problem that code is solving? Not the problem that each individual line of that code is solving in and of itself. This is how are all those magic tricks put together to actually solve a real problem. Be able to write loops, for loops and while loops would be fair game. I doubt very much I would say you have to write a certain kind of loop. I would probably give you a programming question that required you to use a loop. You know, pick your poison. If you want a for loop, great. They lend themselves to counting problems. And I would say at our point right now, a really high majority of the problems we might solve are going to involve doing something some number of times, probably a counting problem. So for loops probably make a lot of sense in our world. But when we first looked at these, we saw that while loops are, you could do counting problems with those as well. All right. But I doubt I would ask you any question that really forced you into like you have to do this with a while loop or something. But you should understand them both. I won't write something with a do while loop, but at least with a while loop and a for loop, it would be fair game for me to give you code that I'm asking you to tell me what does this do using either of those loops. When you write the code, give me a loop. You can pick which one you like. Variable scope is really important. I think it's kind of a hard thing to ask questions about. At the very least, you should understand that variable scope involves where I have access to a specific variable. Where in the program is this variable visible versus where don't I have access to it? We haven't had tons and tons and tons of practice with this yet because we just started getting into functions. But when you're inside of a function, you don't get access to the variables that are up there in main. So I would say there's probably a very low chance that this concept makes it onto this exam, but it's going to be a much more common thing for us to really concern ourselves with when we get into object-oriented programming, where you have certain variables owned by the object that you may have access to inside of other functions, and you need to make sure you differentiate between, do I mean the local variable named A or do I mean the global variable named A, and how do I differentiate between those two? So you should certainly know what I'm talking about when I say variable scope, but I probably won't give you some sort of trick question to say, is this variable inside of, is it in scope in this particular line of code or something? Be able to write a function, in particular, this would be another big star next to this one. When I'm asking you in the programming questions, pay close attention to whether I say, write the code necessary to display the numbers between 1 and 10 to the screen, for example. If I just say write the code, I'm not asking you to necessarily write a function. If you wrote a function for that, I probably wouldn't take off points. But all I'm asking for you is for you to give me the 3, 4, 5 lines of code that would accomplish that task. Write the loop or something like that. The flip side of that, though, is very important. If I say, write a function that takes X, Y, and Z, or whether, some number of parameters and returns something, or if I don't say return something, I say display something, make sure that you understand, A, you're writing a function. Functions have to have a return type, even if it's void, which means they're returning nothing. They may have 0 or more inputs, and the logic needs to go inside of that function. So first of all, if I say write a function, you're going to lose points if you don't write a function. Should be a function. Is that your answer? All right. The secondary piece of that is make sure that you fully understand the difference between a function that returns a value and a function that, if I say it displays the numbers between 1 and 10, that's not returning something. That is doing something. It is printing stuff to the screen, but printing something to the screen is different than a function boiling down to a value that you can choose to use someplace else in the program. You might choose to print it to the screen somewhere else, but you don't have to. So there is a distinct difference between functions that return a value and functions that don't return a value, but do something inside them. So make sure you read those questions carefully, because if I ask for a function, I expect a function, you're going to lose significant points if I don't get a function. Because now you've shown me you don't understand what a function means, right? And similarly, if I say it should return a value versus display a value or do something else, maybe I say write a function that sums up all the numbers between 1 and 1,000 and displays it to the screen, displays the sum to the screen. Well, I'm not asking you to return the answer. I'm asking you to print the answer probably in the last line of that function. So make sure you show me that you understand the difference between a function that does something versus a function that returns something. One is not better or worse than the other. It's just it's solving whatever problem you're actually being asked to solve. Okay, make some sense? Very, very, very few points will be awarded if I say write a function and you just give me some code. All right. And it's not that I'm just being a jerk. That's not showing competence in what a function is. And I'll give you get your your redo on the final, that you show me you finally learned how to learn that skill. Okay. So understand the concept of return. That return really has two functionalities that we need to make sure we care about. Okay. One is it makes a function immediately end. And we can take advantage of that even in functions that don't return a value. So if a function's void, but we need to kill the function immediately, we can use the word return with a semicolon after it. All right, so return can exist in functions that have a return type of void. But return is always going to be used in functions that return a value, because right after you use the word return, you're going to put the value you intend to return. All right, so return really has two purposes: end a function immediately and potentially spit the answer out. Okay, so an important reality of that keyword, because it can be used, having that understanding, you can use it in different circumstances. Having said that, I would imagine that any programming questions that I give you on the exam probably wouldn't be of the complexity where you would have these like intermediate bailouts in the middle of the program that require you to write something with just a return that didn't have a value. But it would be fair game for me to give you code that happens to just have a return somewhere and say, what does this do? Even if it's not returning a value, and you understanding that one of the abilities of return is that it makes a function end, even if it's not spitting out an answer. Okay. Similarly, break. This gets us out of a loop early. Okay, so this immediately ends the current loop that's running. We haven't had a lot of examples using it. And like I said, I probably wouldn't ask you a programming question on this particular exam that's going to be of high enough complexity where this would be a common thing, where you'd have to break out in the middle. But it would be more than fair game for me to show you code that has a break in it and you to be able to tell me what it's doing. And that has much less to do with that. I mean, you should definitely understand how to use break yourself. I just envision on your first test with some programming on it, I'm going to be trying to give you pretty trivial programming questions to really let me gauge where each of you are in terms of basic programming concepts. I'm not trying to trip you up. I'm trying to get a feel for, do you have a little bit of a clue or do you have no clue? Okay, based on where you should be in the class, because I fully expect a majority of you to be pretty weak at programming right now, and that's okay. That's where we should be, right? We're only 7 weeks into baseball season, and all of you just learned how to hold a ball 7 weeks ago. All right, so the expectation is not that we're getting ready for I guess the next Brewer season or something like that. Not yet for us. Primitive types, you should definitely know about. Object types, we technically have been exposed to one object type so far, which is string. But it's a very new concept for us, and because we're not running down the object-oriented path quite yet, you won't really need to be able to understand this connection. between those two quite yet, but definitely no primitive types. It would be fair game for me to ask you a question about strings. I really like string manipulation type problems, so I would say almost expect one of the programming questions for you to be something along the lines of take a string in as a parameter, loop through every element of that string, and do something with it. You know, print the string in forwards, print the string in reverse. Count the number of A's that are in the string and display that count to the screen, or return the number of A's that exist in that string, something like that. All right, so there'll be one programming question at least that has you do stuff with strings. It'll be something simple like that, but definitely involving strings. I probably won't have you on the exam do anything with concatenation just because that's a little quirky, and we just kind of talked about that last class. It's not that it's difficult, but I would say at this point, since I'm just gauging your programming skills, anything that I might say I would typically have you concatenate, I would probably just say, like, instead of build the string in reverse, I would just say print the string in reverse. But then again, now you got to fall back into that knowledge that if I say display something versus return something, that your return type is going to be void. Right? You need to make sure you show me you understand the difference between a function that returns a value versus a function that takes something in but returns nothing, but very likely accomplishes something internally. I won't ask questions about the plus, plus, minus, minus. We talked about that last class, but I hopefully kind of showed that it's not that it's a difficult concept. It's syntactic sugar for adding one or subtracting one from something, but basically never rely on those little caveats with it. Similarly, I won't write code. When I ask you to read my code, I won't give you a program that relies on you understanding that if the plus plus came beforehand, that it means one thing, and if it comes after, that it means something else. I won't try to trick you. All right. So if I say plus plus, it'll almost always be, you know, I plus plus, and it'll probably be in the form of in a loop where it doesn't matter whether it happened before or after, because the number will definitely go up by one. Okay, so the intent will never be to try to trap you into answering wrong. That gets neither of us anywhere, right? And we're just starting to talk about arrays. So this is really our cutoff point here for the exam. So we really just compressed everything we've talked about in the last 7 weeks into whatever, the last 20 minutes or something like that. Easy peasy. A lot of stuff, but should be way less over your head today than it was 7 weeks ago, right? Okay, so any other questions about the exam before we dive into arrays a little bit? So like if I asked you to write a function that counted the number of A's in it, okay, so you would just do an example?
Yeah.
Okay, sure. So we saved. What class is this? Here. 200. All right, so let's say that I asked you on the exam to write a function called CountChars, okay, that counts the number, that takes two parameters, a string and the character that I want to count in as a parameter, and returns the number of times that character appeared in the string. Okay, so it's going to return an int. I'm counting something. It's going to be called CountChars. It's going to take a string as a parameter and a char that we want to count. And this guy should return the number of times this character, the character that lives inside of this char, exists inside of this string. All right.
string S equals char C equals, you have to
In
put
here?
that before- Yeah, you have to put that before main and stuff, or,
Well, I haven't even called it yet.
okay.
Yeah, so if you do something like this in here,
Yeah,
yeah, you're going down a real dark path.
no, and it's, yeah, I meant that.
Yeah,
but-
because functions, you want to make sure you write them generically.
No, I was meaning like before main.
On the exam, I will probably ask you just to write the function.
Okay.
I will probably not say, give me a program that does this. You must write a function. And so you wouldn't have to write the function plus prototype the function and then call it in main. It should be ready for game time related to that, but I probably am mostly asking you to write this guy.
Okay.
All right. So the job of CountChars here is to take in a string and take in the character that we want to count. And it's going to find how many times does this character exist inside of this string. For example, maybe I ask you the question where I don't require you to pass in a generic character. Maybe I just say return the number of A's that are in there. All right. So in this case, I'm counting something. So we're going to keep track of a count, and count's going to start off at 0. I'm going through every element of a string, which is going to say I need to write a for loop that's going to go through every element of that string. I0, I is less than s dot length. I plus plus. Each time through, I'm going to ask a question. If the current character I'm looking at is equivalent to the character I was looking for, if s at bucket I is equal to the character contained in the variable C, then count plus plus. Since I said I'm returning the count, after my for loop here, I will return count. I'm not printing it. And this just really drives home that point. It's a super important thing that a lot of beginning programmers get stumbled with. If I say write a function that takes some stuff and returns a value, the expectation is at the end, you're going to be returning a value. You probably should not print anything in there. All right, but you certainly shouldn't do this. That's incorrect. So at that point, you've done all your right counting, right? I did my counting, I went through, I incremented count whenever I was supposed to, but I never actually returned it. Instead, I just printed it to the screen.
So why isn't 4 int I equals 0, I greater than length? Why isn't
You want me to say I
length-
greater than?
No. Less than. Why isn't that length put minus
Because I'm saying less than here.
1? Okay.
If you want to say less than or equal to
Okay.
-1, because the last legal bucket in S is its length -1.
Gotcha.
But if I'm saying less than that,
It doesn't go to that.
it won't include that last guy. All right, so this is a function right here that counts the number of times this character exists in this string. If instead I said, count the number of times that A appears in the string, well, I would ditch that guy. And inside here, I would just put an A. Count the number of A's that are in there.
But the other way would be.
Makes it generic.
Yeah.
Yeah, now I can call it and say, hey, how many commas are in here? How many spaces are in here? How many B's are in here? I can use that exact same function to operate on all sorts of different interests I might have about the number of occurrences of a character inside of a string. Go ahead. Yeah, so if I call it, so if I say CountChars here and I pass it hello and I pass it an L, for example, the S at bucket I down here, the first time through that will be an H, then it'll be an E, then it'll be an L, then it'll be an L, then it'll be an O. Okay, because this is bucket 0, bucket 1, bucket 2, bucket 3, bucket 4. So in this particular case, calling CountChars hello came in as S, the L came in as C. This loop goes through all of the characters in this case, hello. So it's going to go through 5 times. Each time through, I'm going to say, is that string at position I, which is whatever character it's going to be. So H, then E, then L, then L, then O. is that equivalent to whatever C equals? In this case, C is equal to L. But understand, I wrote this generically. So on the very next line, I can call this same function a second time. And I can pass this guy elephant and say that I want to count the number of T's. So in this particular call to it, elephant came in as S, T came in as my character C, and now this loop is going through 8 times, which is the number of characters in elephant. So I've written the function generically and it's operating on whatever string and char I pass it. It's not, yeah, the output of this will be nothing. The output of this program we're looking at right here will literally be nothing because I'm never actually doing anything with this value. This guy boils down to a count. I'm doing nothing with it. This guy boils down to a count. I'm doing nothing with it. But I promise I have finished counting. I've done the counting. Go ahead. Yeah, so it's going to make more sense when we get into arrays. If we were doing this in a language like Java, this same line would be written as s.char at I is equal to that character C. So this is saying in my string S, give me the character that lives at this position. Okay, so in Java, strings are treated slightly differently than arrays. Or in an older language like C++, a string effectively is an array. We talked about that last class or the class before that, where it is a collection of characters. Anytime you see square brackets here, that just screams arrays in programming languages. And it just so happens that in C++, strings are indexed using array syntax. So if I say S at bucket 0, that says, what's the character that lives at the very beginning of that string? Yeah, this is a position. Yeah, what position, what char lives at position I in the string S? That will boil down to a char, a single char. Go ahead. Right. So I would do something like C out this. I have to do something with that answer, right? This guy boiled down to an answer. Now it's up to me, the programmer, to choose to do something with it. Because all I did in my function here is I said, count the occurrences and return it. That's all that function does, is return that answer. So in this case, I should get a 2 out of hello. And I should get just a 1 for the number of T's, right? So there's my, oh, thank you. Just testing you, you passed. There's my 2 and my 1. But yeah, I mean, you could say something like string S is equal to hello. And then I could pass S in here like that. Similarly, I could say, something like int answer is equal to whatever comes out of there. And then I can say C out answer if I wanted to. Yeah, because variables ultimately resolve to their value. So I put an S, I put hello inside of S, and then I passed S here. At runtime, that S will turn into its value, which is hello. So ultimately, the same thing is occurring. You're just being more generic, but one's not better or worse than the other. If you like breaking it down into individual steps, putting it into a variable, then using that variable, go for it. Makes a lot of sense.
So the variables on top are their string S and chars before even main.
These are in main.
Yeah, but I'm talking about up in.
These aren't variables. This is our prototype for that function.
Gotcha.
These are not variables that are defined for somebody else's use.
Okay.
This is just letting C++ know that, hey, somewhere in here, there will be a definition of a function that returns an int named CountChars, and he expects there to be a string and a char passed to it. Yeah, but these are not variables that you get to use inside of here. They're not variable definitions.
Okay, so the variables are in there.
Yeah, in fact, officially, you don't even have to give the variable names there.
Gotcha.
You can just say there will be a function called CountChars that takes a string and a char and returns an int.
Gotcha.
Because all you're doing is you're advertising to the compiler that you might bump into a dude that looks like this. I haven't written it yet, but heads up, I will be. That's the idea of the prototyping
Gotcha.
thing. Go ahead.
Why, what's the difference between
Yep. Well, right. I'm starting count off at 0 here, but would you agree that somewhere inside here there's potential that count might change? Yeah. So depending on what goes down inside that loop, when I return count here, he might not be 0 anymore, right? He might be a 7 for all I know. So all I'm saying here is return whatever the current value of count is.
You wouldn't have to put that equal to 0.
I would say yes, you do. Technically, the default value for an integer is a 0. So if you wrote it like this, it would probably still work, but this is horrific programming practice.
I
Yeah. If you wanted to start off at 0, you put a 0 in there. It is your job to put a 0 in there. Never rely on default values. And while we're at it, just to kind of let me just do a follow through here, since I made a big deal about knowing that difference between a function that displays the value and a function that returns a value. Let me write an alternative version of this that doesn't return a value, but instead displays it. So I might say, write a function. Let me just put it back the way I had it before, because that's the way I would have written it, like that. Write a function that maybe is called display count chars. That's the name. You can name it whatever you want. That takes in a string and a character, and it displays the number of times this character appears in this string. So now I've said, show it, don't return it. So notice the return type here is void. So I'll go in here. I'll write this dude. And his logic is actually going to be almost identical. But instead of returning count at the end, which would be illegal because I have advertised this dude returns nothing, I would instead print it in here. Cout count end L, like that. So now what I would do maybe here, when I call it, initially, I'm going to make a call to my CountChars. So I define my string, call CountChars, passing it a string, passing it a character. He returns the count. I'll capture that answer inside this variable, and then I'll display that answer. This other one, though, display CountChars, he doesn't return anything. Instead, he takes in a string and the thing I'm counting. He will go through and count it, and then he will actually do the displaying, but does not give me anything back.
You have to put a return if they
End of this?
Yeah.
You better not, because what have I said I'm going to return?
have to-
Nothing. Now, having said that, if you're asking this,
Yeah.
that's not wrong,
Okay.
but I promise you the very next line, that method end, that function ended. So you don't have to kill it off one line early if you don't want to. Yeah, that comes down to that. So if we just want to put it in here,
That's the main-
you can do this. I would say it's unnecessary because in the very next line, this function dies a natural death, right? We're just kind of pulling the trigger one line early or something here. So the idea would be that because return has two abilities. One of the abilities of return is to make a function immediately end. The other ability of return is to also potentially return a value if it were appropriate. In this case, it's not appropriate to return a value because I've advertised this guy won't be returning a value. But in this case here, I said I'm returning an int. When I get to my return, I better package a value with it. Okay. So in this display CountChars, I am not returning a value, but I am going to do something in here, and then I'll make sure the world gets to see it. In this case, I'm going to display it. So that's where we have our, that kind of goes back to what you asked before. How did we make this guy show up on the screen? I grabbed his answer that he returned and I chose to display it. Whereas this dude right here, he doesn't give me an answer. Instead, his whole job is to display it. The side effect, though, is then I don't have that answer later on to do something else with. One's not better or worse than the other, but these are caveats of it. Probably the same error again, right? C out and L there. C out. CountChars. There's my S. There's my L. There's my count. It's fine. This guy takes a string and a char. I gave it a string and a char. Trying to who? Oh, I'm not printing it anymore. I was printing it before. There we go. This guy boils down to a value. I'm putting the value in there. I'm printing it on the next line. Before I was printing it on all in one. In this one, I stored it in a variable. So when I call CountChars, I pass him in the stuff. He does the counting. He gives me the answer back. I'm then capturing that answer in here. Then I'm printing the answer. Then this guy, this other version of the function, he does something a little different. He's doing mostly the same logic, but I'm saying, here's your string, here's your char. Go ahead and display to the screen the number of times that char appears in there. But don't give me the answer back. This one I do, you're right. All right, because this guy internally does the displaying. I'm not doing it externally. So there's my 2 and my 1, my same outputs. But the first one, the output came from me displaying whatever answer was, whatever came out of this function, whatever was returned by that function. In this one, it all happened internally. But understand the difference. If I asked you to write a function called CountChars that takes a string and a char as a parameter and returns the number of times that char appears in the string, it should return an int, and somewhere in there, he should return that int. If instead I said write a function called display CountChars that takes a string and a char as a parameter, and he displays to the screen the number of times this character appears in this string, his return type should be void because he's not returning a value. I didn't ask you to return a value. I asked you to display a value. All right, make sure you have it clear in your head the difference between those two different kinds of animals. Functions that return a value versus functions that just do something. One's not better or worse than the other. It's just what's the right tool for the job. And in the case of an exam, what am I asking you to do? And what are you proving to me that you know, that you understand what I'm asking you to do? All right, makes sense? All right, anything else in our final minute? We didn't get to arrays, but I think we covered some good stuff. Go ahead. I told you exactly how many questions be on the exam. 10 questions. 10 questions, 10 points each. Right there. Yep. Anything else? All right. I will see everybody after break if I don't see you sometime next week, but I will be on Slack during class next Tuesday if you have real-time questions while you're taking the exam.
Quick second.
Yep, have a good one.
Are you able to tell me why? So I was going along with you that last